Yes. Now, can you repeat? Yeah, please repeat the question again. I will try this. Hmm. First, do the question one. First question one by one. Will do. Tell me. One minute. This is a ball moving with 9 meters per second. So that means this ball is going and the ball is like this. Line of their line of impact maybe this way. And after collision, what happens? Okay. So initial velocity is like this way, let us say. After that, it makes 30 degree with that. With this ball and figure is given in the question. Huh? See, both balls are identical, same mass, right? And one of them is moving initially, other one is at rest initially, correct? Uh, First is moving, second is rest. What angle it is, that is not given, right? That is after now, after that. Initially, how much it is making, that is not given. Let's say, means each ball is not moving, no? Only one ball is moving, right? Otherwise, so it is like this means that means it's not exactly head-on collision. It is making some angle which we do not know. Let us say this angle is theta. Okay, some angle theta. So so some angle is theta, and after collision, this body goes at some angle, another body also goes at some angle. Both are making same angle 30 degree with the original line, right? Hmm. So let us say that it goes with some speed. They have given how much speed it is going. They have not given. Okay. Both are identical. Okay, see, when both are identical, just apply this basic idea. Apply. So first of all, you try to resolve itself because this is the velocity. This is the velocity, and this velocity can be resolved into two types. One is this way and component, and one is this way, right? So this will become 9 cos theta. This will become 9 sin theta. Correct. Okay. So 9 cos theta is the component which is in this direction, in along this direction, and 9 sin theta is perpendicular direction. Right. 9 sin theta is perpendicular direction. So first of all, this if you see here that it is already making some this 9 sin theta is perpendicular to the line. Okay, 9 cos theta is parallel to the line. Balls are identical, and this was just. So what kind of collision it is? They have not mentioned that, right? Hmm. Each ball is moving separately. Okay. Hmm. From original direction, they are moving 30 degrees. So suppose no, this one is making an angle 30 degree. No need, no need. This is making angle 30 degree from original, right? And this will also be moving with 30 degree. What speed they have mentioned? How much speed it is? Okay, let's say we take it like this way. Some speed will be there. We do not know. Let us say this speed is v1, v2. This speed is v1 and v2. Okay, but these angles are given 30 degree, 30 degree. Correct. We do not know whether it is up or down. That we do not know. Right. But let us say it is like this. So, but one thing is sure that initially, if you take momentum of the system along this line, there is some momentum because this mass into 9 cos theta, and this is along this, and this mass into 9 sin theta, that is momentum perpendicular to this line. Correct. Okay. Right. So that's what we can do is let us apply momentum conservation. Right. Momentum conservation apply along this line. This is the called line of impact. You know that this is called line of impact. So along the line of impact, let us apply along line of impact. Along line of impact I will take. So initial momentum is only due to this body in this direction. So m into 9 cos theta, right? Mass into this velocity, and this body is anyway not moving, and this first velocity component in this direction, momentum. What about the second? Second, if you see here, momentum. So first body mass is m, and this is v1 cos 30 degree, correct? And second plus m v2, this also cos 30 degree. Okay, let us write it like this. So that's what along this, and perpendicular also you apply along perpendicular to line of impact. What we need to calculate? Okay. So that means v1, v2 we have to calculate, and what kind of collision it is, that also we need to calculate, whether it is elastic, inelastic, like that. Okay, so perpendicular to that in this direction is m into 9 sin theta, and here perpendicular will be m into v1 sin 30 degree, right, plus m into v2 sin 30 degree. Correct. So we have definitely these two equations. That's all. We don't know much about that. Correct. No? Along with this momentum conservation. Along this direction, momentum initially was m into 9 cos theta, and after collision, mv1 cos 30 degree, mv2 cos 30 degree. What is the problem in this? That is what we are doing. Along x-axis and along y-axis we are doing. Okay. Before after only, no, we have to apply before and after only. So now theta, but we do not know anything about theta. They have not given anything about it. Hmm. So from that's what information is. That much information is only given in the question, right? So from here, hmm. Only one ball is running. Only one ball is moving now. One ball is stationary, other ball is moving. Right? Yes. And it is making some angle theta with this line of impact, right? Because it's a two-dimensional collision. Suppose if this theta is 0, then it is a one-dimensional collision only, right? So here it is not a one-dimensional collision, two dimensions, so some angle will be there. That is why we are taking some angle. So from this information, what can we calculate? That much only it is given now. That much only information is given. Anything other information is hmm. What? Can we solve it from here? If it is possible to solve. Hmm. How to solve this? Hmm. Okay. First equation, suppose we cancel m. This is 9 cos theta is equal to cos 30 degree take common. So V1 plus V2 cos 30 degree is root 3 by 2. Second equation is 9 sin theta, and this is V1 plus V2 sin 30 degree half. Correct, na? This is what it is. So if I equate both or if I take ratio, then tan theta will come 1 by root 3. Theta comes as 30 degree. That is one possible solution, right? That is one possible solution. That initial this angle was 30 degrees. Suppose if we go by that approach, so I take this ratio, so sin by cos will become tan theta, and the given V2 get cancelled 1 by 2, 1 by 2, 1 by root 3. That means theta becomes 30 degree. Okay, suppose if we solve theta, after that, how can we solve it? Because cos theta root 3 by 2, then sin theta half. So that means V1 plus, but from here we will not be able to solve it, no? Because that will give only the same equation, correct? No, we will not be able to solve it. We need some more information. Sure. V1, V2 you have to solve. V1, V2. V1 and V2 we need to solve. So V1, V2, how do we solve? If we take theta like this way, then how do we solve? Hmm. Maybe this is not helping us to solve it, okay, because we cannot solve it. So maybe think about something else. Maybe this angle 30 degree may be from this side, because they may have angle 30 degree from same direction or opposite. One is this way and another is this way. Correct now, right? It is possible. So if this is 30 degree this way, and suppose if I change this 30 degree this side, okay. So then what will happen? Tell me. Suppose I consider this velocity as like this way. This way I consider V2, I consider this one. This angle I take 30 degrees. So I think X component no problem, but Y component we have to take Y minus here. Minus we need to take, correct now, right? Because this is going in opposite direction, so we have to take minus. And if you take minus here, so there is a minus factor coming here. So can now we solve it? Can now things make difference? So if we solve it like this, what can we now get? No, no. Here we now need to think of some other approach. So here I think we cannot solve because V1 plus V2, three things are unknown now. V1, V2, cos theta or theta, three unknown. We need one more equation. One more equation we need. Something else is given in the question. Read that again. A original line of motion, not line of impact. Original line of motion means this is. I think we have made mistake. Original line of motion means what? Original line of motion is this one. Okay, this is the line of motion. This is the original line of motion. From this direction, they are making angles. Okay, 30 degree, 30 degree. So we have made mistake here in drawing this diagram. Not the line of impact. Huh? We made mistake here. So here we need to redraw this diagram. So this is the original line of motion. Okay, this is line of motion. Now from this line of motion, one body go 30 degree this side, another body go 30 degree this side. Right? That is what you can consider. Just after collision, just say this. This body is moving this way 30 degree from here, and the second body is moving. This is the velocity of second body. This is making a turn 30 degree like this. Correct? No? This is what it is. There you go. From the line of motion. Okay. So, so that means this line of motion you consider as a reference line then. Okay. That line of motion you consider as x-axis that you can consider. So anyway, second body was at rest, and the second body moves at an angle of theta because second body is moving this way. So definitely the second body is moving along the line of impact, I think. Correct now. This may be the line of impact. Yeah, this is line of impact. Line of impact. Which one? 60 degree. Why? How it is perpendicular? Okay, okay, 1 minute, 1 minute. Perpendicular this would be, yeah, because one is this way, another is perpendicular type way. This angle is perpendicular. So this is 30, this is 60. Correct, correct, correct. This is 60. But in the question, can you read again? Each of them are making 30 degree or what? From the line of motion. No, man. Each cannot be possible. No, no, they are in the same plane only. They're in the same plane. But if you see this, one of this body has to move because it was at rest. If it is moving, then it has to move along the line of impact, which is 60 degree from this first place. Mhm. Right now, Mhm. This is not 3 degree, 2 degree there. because with the line of impact it's making theta, so this has to move in this direction only. This cannot move in any direction. Is there any other friction force also? If friction forces are there, then it is possibly that it can go at 30-degree angle. Might be possible. They have given anything about friction force? Not given. Then maybe you have to assume that this is just not the normal force. Might be this is also the 30-degree only from this. Okay. Maybe you need to take it like this way only. Okay. Let us say it is 30 degrees, we do not know it. Because if normal forces are only there, then definitely this must be 60 degrees. But there might be friction forces also involved. So then this angle is not 60, it is 30 degrees. Okay, right, maybe like this it will go. So, okay, but if you take it like this way, then how will you solve it still? Well, because velocities we do not know v1, v2. v1, v2 we do not know. Okay, maybe here what we can do, maybe here we can solve it by applying momentum conservation along the line, because see, any two perpendicular direction can be taken. It is not that only along line of impact we have to take. So we can take this as x-axis, this direction which they have given. This you can take as x-axis and this you can take as y-axis. Like that we will do. Okay, this you take as x-axis and perpendicular you take as y-axis. Okay, then you apply along x-axis and y-axis, not along the line of impact, not necessary. Okay, so now you change the calculation. This was not clear, na? So figure is not given, so everything you have to interpret properly. Then only you can do the calculations. Okay. So now tell me, along x-axis momentum is how much initially? Initially only along x-axis, because x-axis is, yeah, m into 9, that's all. M into 9 is initial momentum. Uh, uh. So this is 0. Final momentum along x-axis means v1 cos 30 degrees. So m v1 cos 30 degree plus m v2 cos 30 degree. Right. That is what it is, because both are making this component. And along y-axis it was 0. So initially there is no momentum along y-axis. Final momentum if you take m v1 sine 30 degree, then definitely this is downward opposite, so that will cancel out. So downward means minus you can write. So m v2 sine 30 degree. Correct. So from here second equation, I think you can see mass get cancelled. V1 and V2 must be equal then. Correct. V1 and V2 are equal. Speeds are equal. Both of them have same speed. If you know the same speed, then let us substitute here and solve it. The first equation. Right. Substitute this in the first equation. Mass anyway it cancels. So 9 is equal to V1 cos 30 degree is root 3 by 2. And this is V2. V2 and V1 are same. So this is also root 3 by 2. So from here V1 we can calculate. 2 times you take, now 2 will get cancelled. So it will become 9 by root 3. Correct? Check that. 9 by root 3. Okay. This is the speed of each body after collision. Check that. Then what type of collision it is? Correct now. What type of collision also they are asking. So we do not know line of impact anyway. Correct now. Line of impact, how do we know that? We do not know. We don't have any information about line of impact. Correct. But we can, are they asking to calculate E or type of collision they are asking? Okay, kinetic energy then you calculate. Now, conserve means initial kinetic energy and final kinetic energy of system you calculate. So, initial kinetic energy of the system is half m, and first velocity was given as 9. So, 9 square. Correct now? This is what it is. So, that we can calculate. Final kinetic energy of system, you calculate half m v1 square plus half m v2 square. Again half m you take common, and v1 v2 are same, right? So that we will write as 2v1 square because both are same. So half m v1 we have already calculated, so substitute. So 2 into square of this is, I think maybe you can little bit simplify. This is 9, the 3 into 3, so 3 root 3 it is, 3 root 3 meter per second. So square of this will become 9 into 3, right? So that has become how much? Half m 9 square and half m 9 into 6. 9 into 6, 54. This is 9 square 51. So speed kinetic energy is decreased. No, it is not conserved. No, correct? When kinetic energy is less than initial kinetic energy. So kinetic energy is not conserved. That is what we can say. Clear? Yes. Done. Next. Next question. This is how to solve the motion in two-dimensional polygon. You don't need anything. Simply apply logic and try to solve. Any other question you give me? Any other question of two dimension you give me? I will try. We will try that. Next question. Tell me. Hmm. Come on, give me any other question. Put it. Collision. And in that question, they may also ask, is there friction also present? Yes, friction is also present. I told you logically why friction is present. Remember that. Hmm. And it, yes. It is hitting at an angle of theta and bouncing up at an angle of alpha with the vertical, right? And what else? Initially is u and then final. We have to calculate E, right? Coefficient of restitution, correct? So E is given already. Okay, E is given, so we need to find V in terms of U and E and theta and alpha, correct? Now you yourself tell me, na. Today we have seen that. Remember, the if mu is zero, assume that mu is zero here, because if I assume that mu is zero, then remember one result we have got E. I think we have got E. I got as tan, ratios of tan we have got. Do you remember that? What was that? Do you remember that? What did we get? Tan means this final angle. Which one? Initial angle or final angle? Which angle? Because here theta is the original initial angle with vertical, alpha is final angle. Tan theta by tan alpha. Correct. So, okay, now you tell me what we discussed about E also. If you remember, E we have discussed as component in vertical direction approach, and that means V cos alpha by U cos theta. Correct? Huh? That is what it is. So V we want to calculate. So V is equal to E times U cos theta by cos alpha. Now E you can substitute. E is tan theta by tan alpha, or in terms of E only you have to get the answer. Huh? You have to get answer in terms of E only. Then this is the answer. Then this is the answer. E is equal to E cos theta by cos alpha into U. Check the answer. What was V is equal to under root. Hmm, okay, U is outside the root. V is equal to U under root E square. Hmm, this they have given. Huh? Only in terms of theta they have given. Alpha they have not given. Huh? Okay, okay. That means you remove alpha here. That means you got the answer, but alpha you try to eliminate here. That is what is the idea. Correct now? Alpha you try to eliminate. Hmm. How to eliminate alpha? So tell me from here what is tan alpha from this? Tan alpha becomes tan theta by E. Correct? Tan theta by E. And okay. Correct? It is right. Are you writing this formula correctly? Tell me again, you check and tell me, is this correct? Is tan of initial angle tan alpha by tan beta or tan beta by tan alpha it is? Take your notes and tell me. Because correct? Huh? Yes? Okay. So from here tan alpha becomes tan theta by E. I want to calculate cos alpha. Okay, note I want to calculate cos. I will get this, come back to this answer. Only thing is that I have to eliminate this cos alpha in this. Cos alpha, how? Because tan alpha I got. Let us say I draw a triangle of alpha, which is ratio of tan theta and E. So I can take this side as tan theta and this is E. Correct now. So from here, what will be this? So this will be root under E square plus tan square theta. Correct? Hypotenuse. Right. So from here cos alpha I can write as E divided by root under E square plus tan square theta. Correct. Now let me substitute here and check whether this answer is coming or not. So V is equal to E cos theta U by cos alpha. Cos alpha is E under root E square plus tan square theta. So E got cancelled, and this cos theta which is there I will take inside that. That means cos square theta I will multiply. So E square cos square theta plus tan square theta into cos square theta. I think we got the answer now because tan square is sin square by cos square, so it will give sin square. So somewhere I think this is not correct because I think this is E square cos square, right? Ah, that's what. Yeah, that's what we got it. E square cos square theta plus sin square, right? This is the answer. So we already have done this important result. Now little bit calculation you have to do and you got the answer, right? Okay. So not much we have done because already we know those results. We are just use little bit calculation got the answer. Then any other question? Any other question if you have asked? Yes. Hmm. Okay. So this is 3 kilogram. It's a one dimension collision only. So this is U1 and U2 is 0. Stationary head-on collision is happening. Okay, then E is equal to 1. Okay, then that means this becomes this way. So this V1 becomes minus 2 meter per second. What about that body, bigger body? Okay, so it may be going in this direction with some velocity. We do not know. Okay, then what else they are there? That means we have to calculate this one, right? That's a very simple question. Nothing is big in this. Okay, very simple question it is. So based on this information, we have to calculate U1 and V1 is given. So use the formula for V1. What is the doubt in this V1 formula? You know, use formula V1 M1 minus M2 is 1 anyway. Okay, so M1 plus M2 times U1 plus and something time U2, but that second time is 0 because U2 is 0. So this is what you have to do. This you have to take as minus 2. M1 minus M2 is 1 minus 3 and this is 1 plus 3 and this is U1 and this is minus 2 and this is minus 2 and this is 4 and you got the answer 4. That is what it is. Simple. If they ask V2 also we can calculate. We can use the formula V2 and calculate. Then any other question asked? So some nucleus is there, its mass number is 57. So this is another nucleus. Okay, this is iron nucleus. Okay, iron nucleus, and it is emitting a gamma. Gamma is a kind of photons basically. Gamma, gamma photons. Photons are electromagnetic waves similar to light. So it is emitting that, and initially it was at rest. Initially it was rest. Not given means assume it is rest because this nucleus rest. It is emitting something. Okay. Just like a bomb explosion happens, so bomb is at rest and it will explode like this. So they are saying this nucleus, how much its mass is? How much its mass is? Is 6.935 km. This is also AMU, atomic mass unit. Right? These are masses only in terms of another yes. Photons, they don't have mass. Okay, we should understand this. Photon mass is not there. So what are they asking to calculate? Okay, recoil energy means kinetic energy. Okay, so if it is initially at rest, so total momentum is zero, and this is going with this way, and this is going with this way. Okay, this energy is 14.4 kilo electron volt. Electron volt is actually energy units of energy. Okay, 1.66, and that we already know. Yeah, that atomic mass unit we already know. So we need to calculate its kinetic energy, right? How much it is bouncing back. Okay. Now this is the initial parent nucleus, like a nuclear reaction is happening. Okay. So nuclear reaction happening, this is decaying into a smaller nuclei and some photons are emitting. So it's like a bomb. A bomb is explode, yeah, radioactive, and just like a bomb breaks into two parts like that it is. This is one part, this is another part. So momentum conservation will be there and total momentum has to be zero. So this has to be also zero. So this momentum and this momentum must be equal to cancel out, right? To cancel out total momentum to be zero. So kinetic energy, momentum. So how to calculate momentum of photon? I think this momentum of photon is given as E by C anyway. This is concept of light energy that you will study in grade 12. So momentum is E by C. E is the energy and C is the speed of light, which is 3 into 10 to the power 8 meter per second. That you will be studying, of course, in higher 12th grade. So once you know the momentum, then this kinetic energy is p square by 2m, right? P square by 2 mass. So this mass we can already know because this mass is 56.935 into 1.66 10 power minus 27. That means we can convert this mass in kg, right? We can convert this mass in kg, and this momentum is E by C E. We can do calculation. Tell me. Only one photon, na? Are they saying so many photons? The question you read that. That is photon. Photon is the energy only. Okay. Gamma ray is a photon only. Radiation. Radiation is called electromagnetic wave. Electromagnetic waves are made of photons. Photons are like particles of light. Okay. So this is what we have to. One direction only you have to take. Okay. So this you calculate. You want to calculate this energy is 14.4 kilo means 10 to the power 3. An electron volt means charge of one electron you have to multiply. The charge of one electron is 1.6 into 10 to the power minus 19. This energy is coming in joule. Speed of light is 3 into 10 to the power 8. Now this we can definitely calculate. This is a calculation now. Right? This calculation we can definitely do it. I think you can do this 3 12, so 3 4 12 point 38, right? 4.8 it will come in, I think, right? Into 1.6 into here 5 becomes so 10 to the power minus 19, and this is 5, so minus 24. This is what it is momentum. Okay. Now you have to substitute it here. This you may calculate. Okay. This you have to calculate it. 48 into 1.6 is how much? Calculate this. 768. 7.6. 7.68 it is. 7.68 into 10 power minus 24. Correct. Okay, now you substitute here. 7.68 into 10 to the power minus 24 whole square. This is whole square divided by 2 times mass. Mass is this 56.935 into EMU is nearly 1.66 into 10 to the power minus 27. Okay, so calculate roughly how much value. Answer is given in electron volt or is it given in joules? Electron volt means you have to divide electronic charge. So 7.68 into, right? Um, okay, we would not have done that calculation, I think. Okay, suppose if I don't do this, let us keep it as E only. E. So here, what it will be? 4.8 it will be into 10 to the power, and this will be E into 10 to the power minus 5 it will be, correct? Right, so let us keep in that form because E square terms will come and then we'll convert into energy in electron volt. So let us do that. So 4.8 E into 10 to the power minus 5 whole square divided by 2 times mass, which is 1.66 10 to the power minus 27, and to convert into electron volt we'll divide by E. Now you calculate, this will be the answer in electron volt. So 4.8 whole square, E square 1 E get cancel, E 10 to the power minus 10 comes out, and this is 2 into 1.66 into 10 to the power minus 27. So E got cancelled now, that E cancelled. Now E value you substitute here also, E value you substitute. So I will substitute now. So 4.8 square, square means I will multiply 2 times. E value is 1.6 into 10 power minus 19. This is 10 to the power minus 10 divided by 2 into 1.66 into 10 to the power minus 27. So approximately what I will do is I will cancel this 1.6. Who wants to do this calculation? Leave it. So we cancel it, and this 2 I will cancel with 2.4 here. Okay, so we will get 2.4 into 4.8. Now everything is 10 to the power. 10 to the power, you see, this become minus 29 and this is minus 27, so minus 2 comes out. Check out now this calculation. So 24 and 48 you multiply, 32, 16, 19, 96, 16, 11, right? Then 11.52 by this. So 0.1152 approximately I am getting answer. Check that answer. 1 point 1.6 into 10 to the power 1.95 into 10 to the power minus 6 kilo electron. Kilo means then it will be 10 to the power minus 3 factor will come. Okay. So check out the calculations. Take the calculation. 4.8 into E into 10 power minus 5. So 4.8 square E square, we got cancelled 10 power minus 10. And then this 2 1.66 10 to the power minus 27. 4.8 4.8 1.6 10 to the power minus 19 into 10 to the power minus 10. 2 into 1.66 into 10 to the power minus 26. 2.4 4.8. Approximately I have cancelled, so not a much big problem. 24 minus. No, no, that's why we have divided by electron volt. E we divided it. So after dividing it becomes an electron volt. So we have divided it. So minus 19 minus 10 minus 29. So minus 2 will come, and 2.4 into 4.8 into 10 power minus 2. Hmm. This calculation is correct only, no? Right? Check 2.4 into 4.8. So 0. That is 11.52 something it is coming. So 10 power minus 2 is 0.1152. Electron, kilo electron volt is not needed, because here if you see this 10 power minus 6 means, then this 10 to power 3, so 10 power minus 3 will come. This, according to this answer, it is coming 0.00195, correct? No, 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 this is not coming. You check the calculation. This is the calculation we are getting. Momentum of a photon is E by C only. Momentum of a photon is E by C. They have given photon only, na? They have not given any energy, right? They have given any, this energy only they have given. From here only we have to put calculations. Right? Kilo means 10 to the power 3. So 14.4 into 10 to electron volt means EI multiplied. The speed of light is 10 to 10 to the power 8. Momentum of a photon is E by C only. This calculation is correct only, na? Let's check. 3, 4, 2, 1, 3, 9. Correct only. You see comes here. 10 to the power 5 is very small. Correct. So this is square. Okay, so leave it. This is calculation only. There is nothing else you can do in this. Okay? Calculation only. Leave it. Next question. Hmm. Hmm. Then you do some fast calculation. You practice it, or you try to match the some rounding off you can do. Something you can do. Rounding off. Hmm. Okay. Next. Hmm. Any other question? Rabu, Abdul, Darshan? Okay, then we can wind up and you work out problems, and we discuss further on this topic. Okay. Okay, then we'll see. Discuss. Okay. Bye. Yeah.